Here's another example of solving an exponential equation using one of the problems from the online homework. In this case, we can see that both sides of this equation can be written in terms, and can be written as exponentials with the same base because 36 is 6 squared, and so we can rewrite the, that's not a square, 6 squared, which means we can rewrite this equation. So the left side is 6 to the x squared minus 3, and the right side is 6 squared to the x. So because of that, I have exponential rules that I can use on the right side. Remember, when we have a power to a power, like we do here, we're squaring and then we're raising to the x power. But the rule says that the exponents get multiplied. So on the right side I have 6 to the 2x, and on the left side I have 6 to the x squared minus 3. Because I have the same base on both sides, he said excitedly, that means that I can just see when the exponents are equal. In other words, the only way that 2 powers of x, which is what we have here, the only way 2 powers of x could be equal is if the exponents are equal. And so because of that fact, now I have just a normal quadratic equation to solve, and so I can use our normal strategy of putting everything on one side equal to 0 and factoring. And so that means that either x minus 3 is 0 or x plus 1 is 0, which means that my solution set is 3. That's the only way that x minus 3 can be equal to 0, and negative 1. These are easy to check if you want to check. Notice that when x is negative 1, so this is just checking, when x is negative 1, on the left side I have 6 to the 1 minus 3, and on the right side I have 36 to the minus 1. And so if you check, you can check with a calculator or you can think about rules of exponents, but that's true. And the other option would be that, what I say, x equals 3. So if x equals 3, then on the left side I have 6 to the 3 squared is 9 minus 3 is 6. And on the right side I have 36 cubed. And again, you can check that those are also the same thing. So it's very easy to check because those are nice whole number solutions by putting them back into x and seeing that they really do work. But those are your two answers, two solutions for this equation.